Hello, and welcome back to Mr. Carroll's Classroom. Last time we talked about radicals and how to find the inverses of them, specifically for the square root or radicals with an index of 2. This time we're going to go ahead and we're going to extend that idea and talk about the inverse of cubed roots or an index of 3, and also we're going to talk about, in more generic terms, a radical with an index of n, so any radical. Okay, so let's just remind ourselves, what is the inverse of a function? Well, essentially, two functions are inverses of each other if I can plug the inverse into the original and get x back, and also I can plug the original into the inverse and get x back. Both of these have to be true in order for these functions to be inverses of each other. In a sense, an inverse undoes the original, and the original undoes the inverse. Also, graphically speaking, I'm not showing it here, but if you graphed a function and its inverse, they always reflect over the line y is equal to x. Now, the steps to finding an inverse of a function are pretty straightforward. Essentially, all you do is you take the original and you flip the x's and the y's, or in other words, all the x's become y's and all the y's become x's. Then you solve for y, and what you end up with is the inverse of that function. It is worth noting that not all functions have inverses, and also that the domain and the range actually flip whenever from the original to the inverse, and vice versa. So sometimes it is important to keep track of that. So last time we did talk a little bit about the operations necessary to do this. I'm not going to go over this in great detail. If you want the details of this, check out the last lesson. But essentially, with square roots and cubed roots, this is a square root is where we have an index of 2. A cubed root is with an index of 3. But ultimately, we have to really be careful because obviously we're going to square something to take away this operation, to invert this operation of a square root, and we're going to cube something to get rid of this operation of a cube root. However, when we're going the opposite direction, if I start down here with an x squared, which has a domain of all real numbers, and I take the square root to eliminate that, well, the issue is the square root only has a domain of the positive numbers, 0 and the positive numbers, or x is greater than or equal to 0. So that won't actually take care of the entire x squared. So what we have to do is we also have to take care of the negatives. So we take not just the positive square root, but the negative square root as well, which is why we have to list this plus or minus. Now, that is going to be true not for cubed roots, but for generically speaking, if I have any variable to the nth power, and then I have to take the nth root to undo that operation, well, essentially, if n, the index or the power, if that n is even, such as the square root, that n would be 2, then we have to take the plus or the minus. So in other words, if it's the square root, if it's the fourth root, the sixth root, eighth root, so on and so forth, with even numbers here, then we have to take plus or minus. However, we don't have to go through that process if n is an odd number, such as the cubed root. All right, and we're going to talk a little bit about that today. Now, before I go into the cube root, I want to talk about a couple of things, and that is not just the plus or the minus, but also the domain and the range. Sometimes you have to really pay attention to what the domain and the range are of the original, because you might have to restrict the inverse. Now, in this case, you can see the original, this equation here, is the square root of x minus 1. And just noting here that, and this was the last lesson where we go through all this in detail. But anyways, the index is 2, or an even number. So we really have to pay attention to what we're doing with that plus and minus. In this case, we don't have to deal with the plus or minus because we're not going the opposite way. If you start with an x squared and find the inverse of that, then you'll have to deal with the plus or minus. But in this case, we're starting with the square root, so we don't have a plus or minus. However, we are going to have some kind of domain restriction, as you can see right here. The inverse of the square root of x minus 1 was not just x squared plus 1. It was x squared plus 1 only for x is greater than or equal to 0. Why does that make sense? Well, if I graph this x squared plus 1, I'm going to get this entire parabola over here. I'm not showing it right now, but it would have this left half. And the problem is that left half is not present in the original. So we have to restrict our inverse and say, hey, it's not just for all real numbers, it is only for x is greater than or equal to 0, or in other words, just this right side. And you can see clearly now, graphically anyways, that this is being reflected over the line y is equal to x exactly. All right, so let's go ahead and get to what we want to, our extension today, which is what we want to talk about, our cube roots, or in really for any index that is an odd number, okay? So for a cube root, we can look at this graphically, but basically here's the parent function of g of x is equal to the cube root of x, and if I graph this, then you can see that the domain and the range are both all real numbers, which is really important here because when I algebraically find the inverse of this, if I went ahead and went through those steps, then I would get the inverse of g is equal to x cubed. And here is this the inverse with this dotted blue line here, and you can see clearly that it is reflected over the line y is equal to x. But it's also worth noting that the inverse also has a domain and a range of all real numbers. Let's go ahead and list this. So here are our original functions. So I have g of x as a cube root of x, and the inverse of g of x is x cubed. And if I list their domain and range, yes, it is true. No matter what, all inverses, no matter what inverse you take, the domain and the range are going to switch. However, the domain and the range for both of these is all real numbers. So it really doesn't matter, and you don't have to list this at all in your solution. So if I asked you, hey, what is the inverse of the cube root of x? You are completely fine in just writing, well, g to the negative 1 of x is equal to x cubed. All right, so there you go. There's our basic lesson for today. And essentially what I'm saying here is that when you're finding inverses, number one, you have to be really careful with that plus or minus if the index is an even value. Also, you have to be very careful with your domain and possibly range restrictions. However, when we write answers, we only write the domain restriction. But you have to realize that that very commonly with an index that is even, we have to restrict that domain. So write out your domain and the range for the original, and then flip them, and then you can just write in your answer the domain of that inverse, which originally was the range of the original function. Okay. Now, what we showed today, though, is that we're going to follow the same exact process as far as finding the inverse of a radical with an odd index or an odd degree polynomial. But we don't have to really worry about any of that plus or minus business or any of the domain and range restrictions. So actually those problems are much easier. All right, so there you go. That covers this lesson. Hopefully you are all set with finding inverses of any radical you can dream up. And I hope to see you in the next one.